Hello, my name is Grant Kramer, and I am a professor emeritus at the University of Nevada, Reno. And today I start the second part of my series on the health effects of wine, the negative effects of alcohol. Okay, many of us know that alcohol can have negative effects on our human health, but probably many of you don't know that is actually the product of the catabolism of alcohol to acetaldehyde that also contribute significant effects on our health. So let's look at the effects of alcohol on the body. First of all, alcohol is a depressant and a stimulant. It releases endorphins, the pleasure hormones in the brain. Alcohol alters neurotransmitters in different parts of our brain, including GABA, glutamate, and dopamine. It also decreases activity in the prefrontal cortex and the temporal cortex, the areas used for decision-making and rational thought. It can impact the hippocampus and reduce our memory. Chronic heavy alcohol consumption, which is classified as the consumption of at least 40 grams of pure alcohol per day, equating to about half a bottle of 13% alcohol wine or 1 liter of 5% alcohol beer over a sustained period of time, meaning over a number of years, leads to the highest risk of alcoholic liver disease. Ethanol cannot be excreted and must be metabolized. And as I mentioned here, ethanol is metabolized to acetaldehyde by alcohol dehydrogenase, and then further metabolized to acetate. In addition, the catabolism of ethanol to acetaldehyde and from acetaldehyde to acetate produces the compound NADH. NADH is an important energy and regulatory molecule. And I should also mention that in the process of the breakdown of ethanol, there is the production of ROS, or reactive oxygen species, which cause a lot of oxidative damage in the body. So let's look at this a little bit deeper in terms of how it affects our biochemistry and our physiology. First of all, the accumulation of NADH inhibits gluconeogenesis, which is a biochemical pathway that allows sugars to be formed from fats. It blocks the catabolism of lactate to pyruvate and causes hypoglycemia and lactic acidosis. So lactic acidosis is the acidification in your bloodstream and can be quite dangerous. Fatty acid oxidation is inhibited as well by NADH, and this further promotes fatty acid synthesis, leading to what we call fatty liver, the accumulation of fat on the liver, which is a sign of the beginning of alcoholic toxicity. NADH also inhibits isocitrate dehydrogenase and alpha-ketoglutarate dehydrogenase in the citric acid cycle, causing the accumulation of acetyl-CoA, causing the formation of ketone bodies and further acidosis in your blood. Processing of acetate becomes inefficient as a result of this, leading to the accumulation of more acetaldehyde because it's not broken down into acetate as much. So let's specifically look at what I spoke about before, which is the acetaldehyde toxicity. As I mentioned, acetaldehyde is toxic. It's listed as extremely toxic and carcinogenic. First of all, one of its modes of actions is to bind to proteins, leading to structural and functional alterations, for example, of the mitochondria and the microtubules, and induces the formation of neoantigens, which are host antigens that have been altered enough to generate an immune response. Structural mitochondrial alterations caused by acetaldehyde lead to functional impairment, including a decrease in ATP generation, which is an energy molecule that we all need via the respiratory chain. The production of reactive oxygen species and a decrease in acetaldehyde dehydrogenase activity, the enzyme located in the mitochondria that is responsible for the metabolism of acetaldehyde to acetate. Acetaldehyde can also cause headaches and is thought to be one of several factors contributing to a hangover when one drinks too much alcohol in a particular setting. This is our liver. The liver is important for many processes, including the processing of alcohol from the blood. This is where gluconeogenesis occurs. The liver is important for detoxifying toxic substances that we might produce in our body or ingest. And it's also a place where lipids are processed. In the liver, triglycerides can accumulate because they are synthesized there, as mentioned earlier, when gluconeogenesis is reversed or inhibited. And we also have processing of lipids to make the formation of things like cholesterol. So it's a very important organ that does a lot of things in our body. So as I mentioned, alcohol contributes to a liver disease, and some people's livers can completely dysfunction when they have become an alcoholic or drinking too much alcohol. So let's look at what happens here in this process and the percentages or chances that one could develop this disease. First of all, with a chronic alcohol consumption, we start to accumulate fatty liver. So 90 to 100% of the people who start off with a healthy liver develop an alcoholic fatty liver. Of those people, which is almost 100%, 10 to 35% of them will go on to develop alcoholic steatohepatitis. And from that group, 8 to 20% will develop alcoholic cirrhosis, and only 2% will lead to hepatocellular cancer. There's also the possibility of developing alcoholic hepatitis. And from these groups, you can see about 40% of this group from alcoholic steatohepatitis can develop hepatitis. And that can also be circumvented by going from steatohepatitis to hepatitis and then to alcoholic cirrhosis. Now, there are modifying factors to this development, which include a person's genetics, their sex, whether they're male or female, their ethnicity, whether or not they're obese or not, whether they have other underlying liver diseases, their nutritional status, their iron levels, their drugs and xenobiotic consumption, and their smoking status. All of this is coming from an article in Nature Reviews on the alcoholic liver disease. You can find it in this publication here. So this is a map of the global total per capita consumption of alcohol. And we can see that the areas that are in green, and I'm sorry for those of you who are colorblind, but I didn't make this map. The colors here that are in green are lower in consumption, and the colors that are in red and darker red are in higher consumption. Approximately 3.3 million deaths occur every year related to alcoholic consumption, which is about 5.9% of all deaths. We now know quite a bit about the effects of alcohol, and we know and understand the biochemistry behind it. This is a metabolic map. I am not planning to go through all of this in detail, but I want to point out a few things. First of all, we start here and we see alcohol. Alcohol causes inflammation, and the inflammation produces reactive oxygen species. These reactive oxygen species then cause a series of different things to occur, which later on lead to impacts on your DNA, leading to cancer. In addition, these reactive oxygen species are important in the development of fibrogenesis in the liver, and alcohol can also go through a separate pathway, as I mentioned, where it's broken down into acetaldehyde, and this acetaldehyde can lead to liver injury by a number of other different pathways. So there are a number of ways in which alcohol has effects. Up here, we can see that there are a number of factors here that are all leading to liver injury. And just to show that we do know quite a bit, you can see that these pathways are marked out to specific molecules. This is another drawing dealing with the mechanisms of alcohol toxicity. The hepatocytes here are cells within the liver. And you can see that we have studied and found that there are many compounds that affect these pathways and control or regulate this development of alcoholic fatty liver. Again, I won't go into this in any further detail. The point I'm trying to stress here is that we know quite a bit about the mechanisms of alcoholic toxicity. And finally, I just want to go through what the definition of alcohol use disorder can be. It's diagnosed and classified according to a number of the following criteria. Mild AUD is diagnosed if 2 to 3 criteria are met. Moderate AUD if 4 or 5 criteria are met. And severe AUD if 6 or more criteria are met. So what are those? Tolerance. Markedly increased amounts of alcohol are needed to achieve intoxication or the desired effect, or continued use of the same amount of alcohol achieves a markedly diminished effect. Withdrawal. The appearance of clinical symptoms when alcohol consumption suddenly stops. These include anxiety, insomnia, nausea, associated with cardiovascular reactions, and occasionally delirium, such as hallucinations, fever, seizures, and agitation. Heavier alcohol consumption or consumption for longer periods than is considered normal according to government guidelines. Persistent desire or failure to reduce or control consumption. Considerable time spent consuming alcohol. Social activities given up because of alcohol consumption. Continued consumption despite causing or exacerbating physical or psychological problems. Consumption results in failures to fulfill major role obligations. Alcohol consumption in situations that are physically hazardous. Continued consumption despite causing or exacerbating interpersonal problems. And finally, craving. So if you're finding that you have a number of these criteria, then you should talk to someone about the possibility of an alcohol use disorder that you might have and what you may be able to do about it. Okay, so I don't want to be all gloomy here, but let's go through the conclusions here. Alcohol and alcoholic beverages have significant effects on the body. Alcohol in moderate consumption, especially red wine, can have beneficial effects. Excessive alcohol consumption leads to poor judgment, and chronic heavy drinking will almost certainly lead to alcoholic liver disease and possibly liver inflammation, cirrhosis of the liver, and cancer. Again, such outcomes are influenced by your genetics, your gender, your ethnicity, your state of obesity, and other environmental factors. So finally, please drink in moderation to improve your health and not to damage your health. Wine is a wonderful product that can make your life more enjoyable, but it also has a danger to it. By understanding these physiological effects, we can make better judgments of how to have a happy and healthier life. Have a great day.